Okay, so this is going to be our first recording. And as I said, we start out with some fairly easy math topics. So we're going to take a little bit different view of it. We're going to start out kind of like what we did with pre-algebra last year, but we're going to move through it really quickly. The key to dealing with math is to understand how numbers relate to each other. To understand how numbers relate to each other, you must understand what a number is. Probably the simplest and most misunderstood concept in math is just what is a number. If I were to put 4 up here, how many of you, show of hands, would tell me that's a number? Some of you know better because you saw it last semester, right? That is not really a number. That is just a numeral. It is simply an amount telling us how much. That is only part of the story. To truly be a number, it must not only tell us how much, but of what. So it might be 4 cows. So we have an amount, the 4 here, which I'm going to call the count. And we know just what it is we have 4 of. The cows in this case, which I'm going to call the name. So we have a count and a name. Now you might be thinking, oh no, here's one of those teachers who's going to make me label everything or he's going to mark it wrong. That's not my purpose. I'm not going to do that to you. But working with the labels explains why we do things the way we do. Most people have been taught math and have learned math by memorizing processes and never seeing the underlying, there's only a few underlying concepts that control everything. So with that idea of a count and a name, let's take a look at our basic math operations and how they work. Let's look at addition and multiplication. Now you might be thinking, where'd subtraction go? Well, addition and subtraction are really the same operation. Addition's going forward, subtraction's going in reverse. So any rules we talk about for addition also apply for subtraction. And the same with multiplication and division. They're the same operation, forward and reverse. So let's just take a look at an operation of addition with one of these numbers with the 2 parts in it. So let's talk about 4 inches plus 3 inches. What do we get? 7 inches. Good. Didn't know there was going to be a quiz in the first hour. Let's look at what happened with the 2 parts, the count and the name. We have 4 and 3. It becomes 7. We combine the counts with addition. Well, let's look at the names. We have inches, and it becomes, well, still inches. We keep the same name. When we multiply, there's going to be some differences. Let's say we have 4 inches times 3 inches. 4 times 3 is 12, but it's not inches, it's square inches. Yeah. When we think about multiplying 4 inches times 3 inches, usually you're thinking of a rectangle and finding its areas. It's going to come out to be square inches. So if we look again at the counts, we had 4 and 3 became 12. So we still combine the counts. This time we were using multiplication. But the differences in the names, we had inches, and it became inches squared, or square inches. When we multiply, we also combine the names. Which seems like just a small little nitpicky thing, but it has some huge consequences. In fact, it tells us what we can and can't use in each operation. For example, we might have 3 cows plus 5 boys. Does that give us 8 cowboys? No. Or the other way around, 5 boys plus 3 cows. Does that give us 8 boy cows? No. Any of you with a little bit of a farm background can tell me that is a whole bunch of bull, right? Long way to go for a joke. You'll learn that I have a really stupid sense of humor. You'll get used to it. But there's a point behind it. We cannot add cows to boys because when we add numbers, we're going to keep the same name, which means we have to start with the same name. If I have 2 feet plus 3 inches, I can't add those the way they are. Now, fortunately, I can change them as with many forms of numbers. I can change the 2 feet into 24 inches, and now I can add them. 24 and 3 make 27 inches. But sometimes I can't. I might have 5 feet plus 2 pounds. What am I going to get? Trick question. I'm going to get 5 feet plus 2 pounds. I cannot combine those with addition or subtraction because they don't have the same name. Over here, however, with multiplication, since when I multiply, we're going to just combine the names, I don't have to start with the same name. 5 feet times 2 pounds, I'm going to combine the counts. 5 and 2 make 10. And then I'm going to also multiply the names. Feet times pounds are foot-pounds, which is a unit of torque. So it's just fine to multiply numbers that have different names. This goes into all of our other forms of numbers. Everybody's favorite type of number, fractions. Little review. Top part is called the numerator. Bottom is called denominator. I realize my handwriting sucks, and on top of it, I almost said I smell really bad. That would be great. I spell really bad. If anything ever appears up there that you can't read, let me know. I promise you, I was trying to write in English. I just probably butchered the spelling, or just my handwriting sucks. I won't be offended, I swear. So anyway, numerator. What does it mean to numerate? Every 10 years, our government sends out people to do the census to numerate the population. What are they doing? They're counting. That's a count. Denominator. Well, we have different denominations of money, different denominations of organizations. To denominate means to classify or to give a name. So a fraction, the numerator and denominator are really just a count and a name. A lot of people look at that and they see two numbers, 3 and 7. It's not. It's a single number with two parts. Just like having 3 cows or 3 inches, here we have 3 sevenths. And we go to do operations with them, it's going to work exactly the same. 3 sevenths plus 2 sevenths. Somewhere in elementary school, the teacher told you when you add fractions, you must have common denominator. No special rule for fractions, because when we add any numbers, we must have the same name. Combine the counts, 3 and 2 make 5, and you keep the same name, 7. Again, same rules as for any other number. When you multiply, you multiply it straight across. 3 times 2 is 6, 7 times 7 is 49. Again, nothing new for fractions. That's how you multiply every number. You combine the counts, and then you also combine the names, or multiply the names. When we add fractions, two-thirds plus 4/5, can that be done the way it's written? No. They have different names. In a little bit, we're going to look at how we change those names so that we can add them. For right now, they're different, so we're not going to add them. When we multiply, however, we do not need the same name. So we can just do 2 times 4 is 8. 3 times 5 is 15. 8 fifteenths. Decimals and all the other forms of numbers are going to follow the same rules. We'll show those. We're going to get to those as we get through the night tonight, so I'll show you how those all fit in as we go. So let's step back for a second. You might be thinking this all looks great, but how does this fit in with the calculations I actually do? Well, the thing that ties it all together is something called place value. And since you're all familiar with this, I'm just going to quickly throw it up here as a review. Starting at the decimal point and going backwards, what's this first place value? Other way, ones, and then tens, hundreds. And those are actually our three place values. They repeat over and over again. Ones, tens, hundreds, and so on. This first group is our base group. The second group is the thousands group. And the millions group. And billions and trillions and so on. When you name a place value, of course, you name its place value and its group. So this is just the tens place. This is the 10,000s place. We're not going to get into how you name numbers and all that stuff. But what is important is this. If I have a number like 2,738, what you see there, 2738, is an abbreviation. That's not the full number. That full number is 2,000s. Technically 2 1,000s, plus 700s, plus 3 10s, plus 8 1s. That is the full form of that number. With it in that form, it allows us to see every digit of the number has a count and a name. With that in mind, we can understand why we add, subtract, multiply, and divide the way we do. For example, let's say we have 327 plus 512. I'm going to write those out in their long form so we can see what's going on. Now we said that when we add numbers, we can only combine things that have the same name. So these 2 10s here can only be combined with the 110. And the 300s can only be combined with the 500s, and so on. You've always been taught that when you add numbers or subtract numbers, you have to line up the columns and keep them lined up. That's why, is because we can only combine with addition and subtraction digits that have the same name or the same place value. So once they're lined up, we can just go ahead and add. 3 and 5 make 800s, 2 and 1 make 3 10s, 7 and 2 make 9 1s. Now I realize I did that backwards. You normally go right to left in case you have to carry. I do it backwards just to kind of prove a point that there's more than one way to add numbers. The traditional way that you were all taught, where you have to go right to left and carry, is the most common way of doing it. Let me give you an example. $683 plus 298. You start on the right, work your way back to the left, because 3 plus 8 is 11. So you keep the 1, carry the 1. 1 and 8 is 9, plus 9 is 18. Same thing, keep the 8, carry the 1. And 1, 6, and 2 is 9. So 981. Believe it or not, though, that's not the only way to add those. The process of carrying is only about 150 years old. Before that was developed, the way this would have been added, and you don't have to put this in your notes. I'm never going to force you to add numbers a different way. I just do it to prove that there's not just one way to do things. I could actually show you 3 or 4 different ways to add numbers and always get the right answer. 6 and 2 add up to 8. 8 and 9 is 17, carry the 1. 3 and 8 is 11, carry the 1. 8 and 1 is 9, 7 and 1 is 8, and 1. Get the same answer. Now this is a little shorter and takes up a little less paper, probably a little quicker, but there are other ways to add numbers. Now I'm a realist. I realize that you're not going to be doing out a whole lot of calculations by hand. Probably going to get the calculator involved. So I would hope that at least you look at this and say, hey, that's about 700, that's about 300. I'm expecting an answer right around 1,000. So that before you punch it in the calculator, you have an idea of what it's going to be. I have these fat, clumsy fingers. It would not be uncommon for me to try to punch that in a calculator and get an answer like 6,481. Well, obviously there's a wrong, I hit an extra key somewhere. But if I'm not paying attention, I miss that and I write down the answer and I go on with life, and one of my customers gets a real shocking bill. I actually came from an engineering background, so if I did that, other really, really bad things happen. But anyway, subtraction then is going to follow the same rules. Because we can only combine digits with the same name, you have to line up the columns. Now, I'm not going to spend time going over subtraction. We're going to jump up to multiplication. Let's do like 32 times 21. I am going to write these out in their long form. 3 tens plus 2 ones. 2 tens plus 1 1. Now when we multiply, we don't need the same name, which means not only can I combine this 1 1 with the 2 ones, I can combine the 1 1 with the 3 tens. In fact, I can combine every digit in one number with every digit in the other number. And that's all long multiplication is an organized way of doing that, combining every digit in one number with every digit in the other. Normally, we start with the last digit on the bottom number, the 1 1. We'll do 1 1 times 2 ones. We'll combine the counts. 1 times 2 is 2. Then we also combine the names. 1s times 1s is 1s. Then we move to the next digit in the top number. 1 times 3, 3. 1s times 10s is 10s. Now we've used up every digit in the top number, so we're done with this one. We're going to move over to this next digit in the bottom number. When we do that, what were we taught that we had to do down here? Put in a 0 or move over a spot. Leave a spot blank or put in a 0 to fill it in. And the reason why is going to come up here in a second. Now we have 2 tens times 2 ones. 2 times 2 is 4. Tens times 1s is 10s. Putting that 0 in there just made sure our 10s lined up with our other 10s. Then 2 tens times 3 tens. 2 times 3 is 6. 10s times 10s is hundreds. So 672 is what that comes out to be. Again, I'm a realist, and I know the calculator is probably going to be involved. 32 is close to 30. 21 is close to 20. 30 times 20, you're expecting something close to 600. Questions? This next one, long division, I show you just purely for the shock value. Because most people have never seen real long division. It's the one operation where the shortcut is so far butchered from the real process that it's hardly recognizable. To understand it, let's take a look at some basics here. There we go. When we first learned how to multiply, let's go back to that here quick. Before you memorized your tables and knew that 5 times 3 was 15, how would you figure that out? You got it. 5 plus 5 plus 5. Multiplication is repeated addition. We said division is just multiplication in reverse. So division, 24 divided by 8, is asking, how many times can I subtract 8 from 24? It's repeated subtraction. 24 minus 8 is 16, that's once. Minus another 8 is 8, that's twice. Minus another 8 is 0, that is 3 times. 24 divided by 8 is 3, because you can subtract 8 from 24 3 times. Well, what if we had 27 divided by 6? We do the same thing. 27 minus 6 is 21. That's once. Minus 6 is 15. That's twice. Minus 6 is 9. There's 3 times. Minus 6 again is 3. That's 4 times. Can we subtract 6 again? No. So 27 divided by 6 is 4 with a remainder of 3. We can subtract it 4 times with 3 left over. Now, as we go on, we're going to learn how to convert that into a fraction or a decimal and all sorts of fun stuff. But for now, that's where remainders come from. So with that in mind, let's do a long division. Let's take 38,672 divided by 23. We just said that division is repeated subtraction. Well, I could start subtracting 23 from 38,000, but we'll be here for a while. So there's got to be a quicker way to do it. If I could subtract a huge chunk of 23s all at once, I'd make it go faster. And that's exactly what long division is. We look at this number that we're dividing, and we look at the place values. The first place value here, what place value is that 3 in? 10,000, right? So 10,000 times 23 is 230,000. Can I subtract that from there? No, that's too big. So the next place value is the thousands. What's 1,000 times 23? 23,000. Can I subtract that? Sure can. subtract 23,000 is going to leave me with 15,672. Now, I didn't really subtract 23,000 once. I just subtracted 23 1,000 times. My next place value would be 100. 100 times 23 is 2,300. Can I subtract that from what's left? You bet. Looks like 6 times. Let's try it. Times 6. 13,800 looks to be right. I subtract that, 2, 7. So 1,872 is what's left over. Now, I didn't really subtract that 6 times. I subtracted 100 times 6, or 600 times. I subtracted 23. Next place value would be 10. 10 times 23 is 230. And I'm guessing I can take that out of here. Can it go 8 times? Yeah, I can go 8 times. I subtracted out 8 times, leaves me with 32. Again, that's 8 times 10, or 80 more times that I just subtracted the 20, or 23. And next is just the ones place. 1 times 23 is 23. I can subtract that once more, leaving me with 9. So I subtracted 23 once more. So I subtracted 23 1,681, and there's a remainder of 9. So 38,672 divided by 23 is 1,681 with a remainder of 9. Now that's a lot of paper, a lot of processes. But that's exactly the thought process you're actually going through when you do the long division that we were taught. We were taught to take the 23, you look at the first digit. Can 23 go into 3? No. So that's kind of what we did here. The 10,000s, it doesn't go in, so we didn't do it. Move to the next digit, the 8. Does 23 go into 38? You bet. That's once. So 1 times 23 is 23. We subtract 23. Now, if we look here, this looks different. But what you realize is this here is the same as what we did here. We just left off a bunch of zeros. As you go down through the process of long division, it's all here. It's just we left off some of the extra stuff to shorten it up and make it go quicker. Now again, I expect most of you are going to use the calculator for long division. It's the one operation that I refuse to do by hand if I can possibly avoid it. So I don't blame you for using the calculator on it. Since it's the first night, well, I think we're going to take our break there. We'll come back. We'll take about 10 minutes. Let's come back at about 6:27 or so, and we'll start lecturing again.